Hello class, my name is Daniel Lee and today I will be presenting over carbon fiber, the chemistry behind it, just kind of a basic overview. Um, to start with, I'll just give you guys a quick heads up or roadmap. First, I'll be talking about what exactly carbon fiber is, the structure of carbon fiber, the types of carbon fiber, how it's made, as well as the applications that are used today. So, what is carbon fiber? Carbon fiber is basically, if you can't tell from the name, it's a fiber made up of carbon atoms, and it's usually between 5 to 10 micrometers in diameter, which is very, very small, um, as you know. Uh, these carbon atoms usually lie parallel to the long axis of the fiber, which kind of is one of the reasons why it's so thin. And basically, these thousands of these fibers are woven together to form what's called a tow, which is just basically a thicker thread. If you guys can like picture a rope or like woven yarn, it's just similar to that. And it's this towel that's actually used in various applications. I couldn't really find anything that uses a single carbon fiber. Normally, it's these thicker threads that are used. And this can be used also, it's this fi carbon fiber that's used to combine with other materials to form what's called a composite. Usually it's to help reinforce it because carbon fiber is known to be very strong for its weight and for its high tensile strength, I guess. So the structure of carbon fiber is kind of what gives its strength. There's two different structures, and they're um, both based, whatever structure the carbon fiber has, it's really depending on the type of carbon fiber, which I'll get into later. But as you can see, the one on the left is called graphitic carbon, and what it is it's kind of similar to the structure of graphite. If you guys are familiar with that, it's sheets of carbon are laid parallel to each other, and between those plates itself, uh, ha they're attracted to each other by van der Waals forces, and there's so many of van der Waals forces, and they're all packed closely together that it ends up giving carbon fiber its really high strength. While non-graphitic turbostratic carbon fiber, what actually ends up happening is it's no longer straight parallel plates, but it's almost as if each carbon plate is crumbled in a way, and these crumbles all line up and fit together to have like kind of increase this strength even further of the carbon fiber. And then the main difference between the two is because graphitic carbon has those van der Waals forces and stacked carbon plates, it has a higher Young's modulus, which basically means that it won't stretch very much at all. You can almost think of it as being kind of stiff, like there won't be that much bend, there won't be that much stretch. While turbostratic carbon has higher tensile strength overall, meaning that it's a lot harder to break because of those wrinkles and those kind of like crumpling of the plates and how they fit into and interlock with each other. So basically, there's about three types of carbon fiber. Um, there's a lot more classification, but those classifications are more focused on how thick and how long and how many threads are used. But there's really three main types, and how they're classified is depending on what kind of precursor was used. The three main types are polyacrylonitrile, which or PAN for short, rayon, which is a cellulose polymer, or it's like structure similar to the cellulose polymer, and pitch, which is kind of like the tar-like substance from trees. And about 90% of carbon fiber production is actually PAN, with the other 10% being rayon and pitch. So, and like I said, within these three types, there are numerous qualities and grades for carbon fibers, usually each with a specific purpose in mind. But rayon, it has, as you can see, it's actually the same polymer as cellulose. But the difference is it's a lot shorter. It has about 400 to 700 degrees of polymerization, while something like cotton would have about 5,000. And also, um, PAN and rayon are actually both turbostratic precursors, while pitch is considered graphitic. So basically what that means is carbon fiber made with pan and rayon are gonna give you turbostratic structure, the one with the crumbles and stuff, while the pitch will give you the graphitic. So there's obviously, depending on the type, the production will be a little different. But the general concept is to heat the precursor at a very high temperature in an anaerobic condition, which basically leads to the fibers being made up of almost 100% carbon, thus making a carbon fiber. So there's 5 steps. First, it starts with spinning. So spinning is basically the precursor. In this case, the picture shows polyacrylonitrile or PAN. The precursor is just mixed with other ingredients and then it's spun into fibers. And then the next step would be stabilizing, which the fibers get chemically treated to, make sure it's stable and there's, nothing else that's impurities are gone and stuff like that. And then the next step is carbonizing, which is this is when the fibers are heated at very high temperatures in that anaerobic condition. So, because there's no oxygen, it doesn't light on fire, but at the same time, it does break down into carbon atoms. Yeah, and then this forms the carbon crystals that later become very important, obviously, for the structure of carbon fiber. And after carbonizing, there's surface treatment, which is basically the surface of the fibers are oxidized to kind of improve the bonding between the atoms. And then after that, it's sizing, which is basically these fibers will then get woven into their various sizes that whatever it needs to be. So let's say they need a diameter that's a millimeter thick, then the sizing would weave those fibers into a millimeter or 2 millimeters and so on and so forth. So there's actually a lot of applications with carbon fiber. Most of it has to do with reinforcing composite material. The highest demand of carbon fiber is actually from aircraft, wind energy, and the automotive industry. And the reason why is because it has such a high strength to weight ratio. Like the tensile strength is so high, considering its weight, that it's really good for things that need to be lightweight but very strong, like aircraft. Um, so its main application today is reinforcing composite material. There has been some research done in terms of buildings, such as like reinforcing concrete with carbon fiber or rebar with carbon fiber, but it's not a commercial application yet. It's just in its research stages. But then, so then, the next main application of carbon fiber is actually reinforcing fabric. So, the picture below is a motorcycle glove, which is reinforced with carbon fiber. And it's just, I don't think there has been any research or anything done for in terms of military, but it just to reinforce clothing for impacts. So like in this case, a motorcycle for if there's a crash. And then there's also some applications in microelectrodes, which is using very, very thin carbon fiber. Um, it, it's not that popular, but has a very niche field in that. And then also there's an application of flexible heating because if you can run, you can kind of, I think the chemistry behind it is you can run some electrical current through it and then it'll end up being able to heat, it'll heat up like the one on, as you can see on the picture on the bottom left, it's kind of used to make heating clothing. However, it's not super popular as well, and it has been prone to, catching on fire, which is not a good thing. But yeah, so these are the but the main application is the reinforcement of composite material. Here's my list of references, and as always, you can ask any questions in the forum on eClass. Thank you.